So, Newton's laws of universal gravitation state that the force of attraction between two bodies, look at it now, the force of attraction between two bodies, let me say body A and body B. Body A must have a mass, which is m1, and body B must have a mass, which is m2. So the force of attraction between these two bodies is directly proportional to the product. When you say product, directly proportional to the product of their masses, m1 times m2. And inversely proportional to the square of the distance separating them. The distance from here to here, from center to center. So it's also inversely proportional to the square of the distance. Inversely proportional to the square of the distance separating them. So you take R as the distance separating them. That is it. So R is the distance, don't forget. M1 and M2 are the masses of the two bodies. So you have the distance between them. This is what the law says. So when you have a variation in mathematics, there must be a constant of proportionality. So you can now say from there, force equal G M1 M2 over R squared. That is what the force is. So you have the formula now. So the gravity, this is what you are to dimension. So you want to dimension the gravitational constant. So you need to make G the subject of the formula. This over 1. So when you come multiply, you have G M1 M2 equal F R squared. That is F times R squared. So you divide both sides by M1 and M2. So you have it over M1 M2. So you have M1 M2. This and this cancel. So you have your G now equal F R squared over M1 and M2. So you got the formula now. Because before you can dimension a particular parameter, a quantity, so you must get the formula ready. So the formula for the gravitational constant is force times R squared over M1 times M2. That is the formula now. Then when it comes to dimension, so three fundamental quantities are very important. It's upon them others quantity are built upon. So the first one is time. Time is dimension as T, capital T. That is it. And the unit is second. Then you have mass. Mass is dimension as capital M. That is how you dimension mass. Then you have the next one, which is distance. Distance is dimension as what? As L. So when you have distance, is taken as what? As L, which is a meter. That is the unit of distance, meter. So your mass is a kilogram. That is how you get it. So these three parameters are very important. Upon the three, other quantity are built upon. So you can see now from the formula you check for the fundamental one. When you check for the fundamental one, you can see how now. The R here is the distance. That is L. Distance separating them. There are two distances there. So you can see you have L squared. So your R squared, from there, your R squared is taken as L squared. That is dimension is done for R. Then M is dimension as what? As N. So your M1 and M2 is now the capital M squared. That is what you have. So from there, if you put them into the formula, so you have gravity equal force L squared over M squared. So you need to break force. It is force you have to work upon. So this one is dimension, this one is dimension. So you have to work on the force. So in physics, force is equal to mass times acceleration. That is what force is in physics. You can see mass is there inside the force again. So mass is dimension on its own. Then you have to split acceleration. So acceleration is what you split. Acceleration is velocity over time. So you can see time is also there, which is dimension as t. Then you have to split velocity. Velocity, on the other hand, is equal to distance over what? Over time. That is what velocity is. So you split velocity, distance over time. You can see time is already here, then distance and time, they both are there, a fundamental quantity. So distance is dimension as L, so you have this to be L over what? Over T. So when you have L over T in physics, it is as good as say L t minus 1. That is L over t, because there's 1 over t there. So 1 over t is t raised to the power minus 1. So you have LT minus 1. That is your velocity. Distance over t, L over t, that is LT minus 1 velocity. So you can bring your velocity and put it here to get acceleration. So acceleration will now be velocity, which is this, LT minus 1, and that t is also here. You can see the t there now. So you have to work with this t and this t. L is there, work with t and t. T raised to the power minus 1, then over t raised to the power 1. So division here will change to subtraction. So there's law of indices here. You have the same base, and the division is subtraction. There's 1 here. When this division changes to subtraction, you have minus 1. Then t raised to the power minus 1 minus 1 will now give us LT minus 2. That is from acceleration. Acceleration is LT minus 2. So you have acceleration from here. You can put it here. So to get your force now, force is equal to mass times acceleration, and mass is capital M. Then acceleration is LT minus 2. So you have your force. Your force is done. Then you now go and put it into the formula. So don't forget the formula for gravitational constant, which is G equal FR squared over M1 M squared. That is it. That is what we got for the gravitational constant. That is what we got from the gravitational constant. So from there, you can bring your force now. You can put it here. So you have the gravitational constant, which is force. That is M LT minus 2. Then R, which is L squared over M squared. That is what you have finally. So the force alone is MLT raised to the power minus 2. That is what you have here. Then the radius, which is the distance, is L squared. Then the mass, which is M squared. So let's solve the problem now. So mass square, one mass will cancel. There are two mass here. So you have left LT minus 2, then L2 over one of the mass there. So you can see L and L. We work on L and L. L raised to the power 1 times L raised to the power 2 will give us L raised to the power 3. So will now give us L over 3 T minus 2 over mass. That is what you have eventually. Then from here now, so the dimension for the dimension now is now L3 T minus 2 over N. That is what you have. So from here you can bring out the unit. You can bring out the unit. So in case this option is not available, so you can see this is supposed to be the final answer. But in an event whereby you don't have this option available, so you can still simplify this one. This one can be simplified. So don't get me wrong. This is the final answer. But in some cases you may not have the answer like this. That means they simplify it further. You can still go further. So you can work on this one now. This t raised to the power minus 2 is as good as L3 times 1 over t squared. That is it. Then all over m. That's the meaning. That's the meaning. So this one now is division. So you can now have it finally to be L3 over t squared then n. So that is it. So take notes. So this is also this and this means the same thing. So I just apply law of indices here. So I'm just talking in an event whereby you solve the problem. So this option is not available. This one must be available. From this or this, you can bring out the quantity of you can bring out the units of gravitational constant. So from there, let's see now. Don't forget I told you that L is taken as n. That is what L is taken as. L is taken as n. So you have meter cube as a unit for L. Then look at T now. Per second square. Then mass is kilogram per kilogram. So the SI unit of gravitational constant is meter cube per second square